Hey everyone, welcome back to 30 Days of Python. Today is day 12 and we are focusing on modules. So let's think about this. Without modules, all your code will be one giant file, right? That's quite difficult to navigate around. Modules give a complete meaning to object-oriented programming. You'll be able to organize your code logically, reuse your own work, and tap into a massive Python ecosystem of pre-built. A module is simply a file containing Python code, your code. Modules are like chapters in a book. Instead of one giant document, you have organized solutions that each handle specific responsibilities. This will make your code maintainable, which makes it easy to find and fix issues. It is reusable, which means it uses the same module across projects. It's collaborative, making it functional amongst many developers. And it's scalable, allowing you to grow the project without creating chaos. Python comes with a massive library of built-in modules. You call these libraries by importing them at the top of your code, usually from the first line. Like the math library, you can use this to do the complex mathematical calculations. There is also the import random library that allows you to generate random numbers or make choices at random. The import date time allows you to work with dates and time, like the example we see here. The now function calls the current date and time, outputting today's date and time in the 24-hour clock. There is also file handling, web requests, databases, and much more. You really need to build anything from scratch. As said before, we use the keywords import to import libraries. However, there are other ways to do so, such as import as. You specify the library you want to import with the keywords as you give it a variable name. This is useful for long module names. You could also import specific functions and classes using the keywords from, specifying from which module and then importing the specific classes. You can also import everything regarding the module. You use the asterisk if you're importing everything. You can then combine words to rename the module you are importing. For best practices, use the basic import for frequently used modules. Use specific imports for clarity and avoid the import asterisks because it causes like naming conflicts and stuff. Now let's create our own modules. This is how you organize your code across multiple files. For example, we create a file called calculator.py that contains simple calculator modules. Another file called main.py uses our custom module by the keywords import and calling it. As seen in this example, we can call the functions that exist inside the module calculator, such as add and isEven. An alternative import method is to also specify the function to be used from the module, like multiply. So you can see how clean the code is by just creating modules with functions that define our needed functions. Each module would then serve its purpose and the main file would remain organized and readable. Now let's look at one important pattern you will see throughout your dev career, and that is _name, and the double assign operator, and in quotes, _main. What does this mean? If you look at the example in the utilities.py file, when it runs directly, the name that contains the underscore is main, as seen by the if statement. So the main function is called and ran in the process. If you were to import utilities in another file, in other words, the main in quotes will change to utilities, then the main function will not run. In the example, you can see that the print statements are giving the hints of what runs when. The main will only run if the file is triggered to run directly, but if indirect triggering occurs, in other words, the file is imported to another file, the main will not trigger and only the function that was called, as seen below with the main script file. When your project grows, you tend to scale the project. With doing so, you need to organize multiple modules into packages. It's simply a directory containing Python files. I myself have never implemented this good practice when attempting to build things, which means it's a good time to start, right? Let's look at the structure. You have a project folder, my project, and in that directory you have the main Python file with another directory or folder, my package. Inside my package, it contains 3 files and another folder. The files are initialize, math ops for mathematical operations, and string ops for string operations. The folder utils then contains all the files you consider utilities, such as the helper files. The init files in each directory tells Python that these directories are packages. They can be empty or contain initializing code. Big scalable projects are organized this way. It is easier to know where your code is rather than searching an enormous file. To use the files from each directory, you call them from the packages like this in the main file. From the package directory, in order to call the utils directory, you say .utils, specifying that the directory is in the current directory, and then import the module you want. You could go further into Python modules available to you by looking at third-party modules such as pandas. We install these modules using pip. In your install, request pandas numpy. Since we have Python installed on our computer, we can now use pip to install packages and modules. We can now import numpy and pandas into our Python code and begin using it like it's our own modules. Let's go over some best practices for working with modules. We're looking at organized imports. It's best to import libraries in a line-by-line structure rather than one line. This is not about being efficient in coding practice, but rather organized in what is being used. It's more readable this way. For module structure, it's best to always have the main Python file in the outermost parent directory as seen here. Everything else can be put into directories and subdirectories to be called upon, which brings us to common mistakes made. Circular imports. Module A imports module B, or B imports module A. The naming conflicts, like importing with the asterisks for everything, can cause problems. For packages, forgetting the init Python file, incorrect handling of import errors, so try putting it in a try catch. We'll deal with try catches later on, but for now, just know it's best to put it into a try catch block when outputting modules. Right, so there you have it. We're getting better at understanding Python and how to make the most of it in our development journey. So we have learned to organize our files and code today for maintainability and scalability. So please consider subscribing and leaving a like if you found this helpful and want to continue with me on this 30-day journey of Python development. I will see you for day 13 as we dive into list comprehension. Cheers, see you then.